So this is about linear functions. So the first thing is that a linear function, which is often called y, is always of the form mx plus b, and it might be written other ways. You might see it like this, but you can, y1 is just a number and x1 is a number. So this is mx minus mx1 plus y1, just distributing and then adding the y1. And this is all just a number, so that there's b. So it's the same. No matter how you see it, it can always come down to this, where m is what we call the slope and b is the y-intercept. So let's talk about the easiest thing first. B is the y-intercept. So if you have y equals 3x plus 7, that tells you right away, go up to 7 and put a dot. That's a point on it, because if I put 0 in for x, then y is 3 times 0 is 0 plus 7. So 0 is x, you get the y-intercept. The slope is, that's not really to scale, but anyway, the slope says how y changes with respect to x. So it's a rate, it's an average rate of change. It's a rate of change in the case of a line, but it's an average rate of change if you calculate slope between any 2 points on a graph. And rate of change, you're used to thinking about like miles per hour and things like that, and so you put say 113 miles in 2 hours, and that's how you determine, right? And so you end up with this 56.5 miles per hour, which you write in pH. So this is the same thing. We're saying how many y units did I go in x units. So it's a rate. It's a y per x rate. So 113 miles is how far you went. It was the change in your location. 2 hours is how long it took. That was the change in your time. So instead of having change in distance over change in time, we have change in y over change in x. So change in y over change in x. So this is the y you ended up with minus the y where you started, divided by the x you ended up with minus the x where you started. And you can reverse these because the slope of the line is the same no matter which way you're going on it, but just reverse them both. Whichever one was your initial point in your mind, make sure both of those are there. So if the 2 points are 2, 3, and 5, negative 4, then if this was my initial point and it's there, then negative 4 goes here, 5 goes here. So what you don't want is to have a 3 here and a 5 there, because they are not together. So that's a point and that's a point. So the slope between 2, 3, and 5, negative 4 is negative 4 minus 3 over 5 minus 2, or 3 minus negative 4 over 2 minus 5. So these are the same, negative 7/3 in either way. And a lot of times you'll hear the phrase rise over run. So if I want to have the point 25 and slope 3, then I can, on the one hand, graph this. So 1, 2, 1, 2, 3, 4, 5. Slope 3 means when I go 1 to the right, I go up 3. So I could go over 1, 1, 2, 3, or back 1, down 3, which is a little more on my graph there. Just draw a line through it. You only need 2 points to make a line. I can also write an equation, and I just have to say, well, this is a point on it, so I'm going to plug in, substitute for x and y. subtract 6. So I guess I didn't draw this very well. Okay. I know you guys have seen lines before, so the only other thing maybe is to talk about average rate of change. The average rate of change between 2 points on a graph is the slope between the 2 points. So if you have, say, y equals x squared minus 4, and you want the average rate of change between x equals 1 and x equals 3, then you take y for 3 minus the y for the 1 and x at 3, x at 1. So if I plug in 3, I get 5. If I plug in 1, I get negative 3. So the average rate of change is 4. That's the slope between the points 1, negative 3, and 3, 5. You could also just be given a table, but that's still a function, right? Because you still have values mapping to each other. So if you're given a table, like that, and you ask for the average rate of change between these two, say, then you would just do 2 minus 6 over 5 minus 4. And that's your average rate of change. And that just means whatever this function represented, on average, decreased 4 for every unit between 4 and 5. And those could be years, so it could be, you know, that there was a different amount of change every day, but the change between the 4th year and the 5th year was, on average, negative 4.